What I want to do is spend some time talking about OWASP Glue, which is a project that I work on and started somewhere around 2013. Want to take just a brief second and introduce myself. You don't need to take a picture of my bio. Sorry. So I'm actually on the OWASP Global Board right now, but I'm here really more representing the project because Omer has been running it lately, and so I want to first acknowledge him. He's kind of primary, and he's been writing the most code and so forth, but he's in Israel, so he was not able to present. So normally I would not feel real comfortable getting up at an AppSec and talking as a board member because it feels like the wrong dynamic. But I wanted to talk about the project, and I wanted to just put it in context of, hey, like I was a software developer for a really long time, and then I basically had my stuff broken, turned in, like a lot of us, started working on security. And Glue emerged essentially because we wanted to solve automation problems. Actually, let me just also acknowledge Brian. This is sort of roughly in order of current activity. But we've had a bunch of people work on it. We used it at a couple clients, so we've sort of built it, purpose-built pieces of it to solve problems at clients, and they let us open source that as part of the tool. I could talk more about that. I'm term limited, so I'm done on the board in December, so hopefully I'll be able to spend more time on this again. I really like the project. It's obviously at OWASP Glue on GitHub. And what we're trying to do is make automation easier. And so it's not, in a lot of ways, it's not a security tool. It's more of like a meta tool to make automation easier. And so what I want to do is explain that. And these are Omer's slides, so I want to give him full credit here. The idea here is we're taking a task, like one of these things like SNCC or ZAP or checkmarks or so forth. We want to run it, and then we want to figure out what we're going to run it against, and then we want to collect findings, which are like the candy. And then we want to take the findings and we want to filter them out, because most tools don't have false positives, so we don't have to worry about that. And then we want to report those somewhere like Jira or TeamCity. So the idea here is basically to get a pipeline together. Here, let me go back, right? So we're running tools. We want to be able to target, and this is representing source code. This is representing like a live running application. This is representing like a hard, like just a file on a file system. And so what we're trying to do is abstract all of these things so that it's easier. We also produce a Docker image, so you can run Glue very easily. And hopefully, as you'll see, that actually opens up some fun possibilities, right? So if you wanted to right now, you could go say Docker run, and I do the --rm, so it removes the Docker image when you're done, because unlike many Docker images, it's not like an Nginx service where you want to leave it running. You want to run it once and let it go away. And so the RM removes the Docker thing when you're done. So the -h, as you might expect, shows help. Here, I'm running a tool. So this -t tells me I want to run a tool, and I'm running Brakeman, which is an open source Rails static analyzer. And I'm running it against this vulnerable application, which is intentionally vulnerable. If you ran this right now, Glue would produce a bunch of findings. And you don't need to do any other work to set it up, which is kind of the whole point, right? To change the tool, I just change what I'm running. So the -t, this is a sensitive file lookup. So if you have certs in your file system, or you have passwords or private keys, those kinds of things, this will find, right? We also support the idea of labels, so you can run all of the tools that are related to code. And I'll explain a little bit more about how we know what the labels apply to. But instead of running tool by tool, you can run all the code-related things. Here, I want to show a deeper, obviously people wanted to run the tool, but they wanted it to run and produce the results where they wanted them. So what we do is we take all the results from Brakeman or whatever, standardize that into a common finding format, and then report those wherever you want them to go. And Jira is one of the places people want them to go. So we can say we want the format to be Jira. We have to give it the URL. So like this works if you're, like we have a gemini.atlassian.net URL, but whatever yours is, you can run if it's hosted. It's doing sort of basic auth in this scenario. So if you were using this in an enterprise, you'd probably have to solve this auth problem. That's not like out of the box easy for you necessarily. But you tell it the Jira project, and now when it runs SFL or Retire.js against your project, it's going to report those issues into Jira and basically post them into that project, which is handy because now you've got a list of those. On a side note, my experience is you want to start by having like a security project or an AppSec project in Jira. You don't want to dump these directly into the developers' Jira projects right away until you figure out what's going to be there, right? Because otherwise you're going to make a lot of noise. We like to get to the point where we can have it be part of their CI/CD. It's running in Jenkins, which I'll show you in a minute, and it just pushes to Jira. That's like what we want. But initially, I would suggest running it to a place where you can manage it and figure out which things apply. This is just more detail about Jira, but the thing that I want to point out here is there's a filter, so we won't create the same issue more than once in Jira. So now we have sort of a way of managing duplicates, right, or change over time. So if I've seen a certain problem and reported the issue to Jira before, and I can search Jira and find it, I'm not going to report it again. So that's kind of one of the strategies for managing noise over time, if that makes sense. So I wanted to talk a little bit about the architecture of Glue, like how we built it, like what the stages are, as you'll see, and happy to answer questions, but we'll look at code in a little bit about what each of these are. By far the most common thing that we've done is use Git repos, so we'll point at I usually just point at public Git repos for demos, but you basically have to be able to connect to somewhere to pull source code. So usually a lot of the tools that we've used the most are the source analysis. So we're pulling source code from Git, and then we're going to do something. But we sort of want to abstract how we got that, because we want to be able to run it against a file system if you got the code some other way. We want to be able to look at ISOs. When we first did this, we thought we might look at like AMIs and like dig in and do deeper, interesting things on AMIs. That stuff is not as robust as some of the other stuff. And we don't really do a lot with Docker images either. We'll untar them and do certain things like check for obvious. We'll run ClamAV against that, but that's not all that, I don't know that that's all that useful. The main thing we're doing that I think is useful is this, like we're mounting, getting the thing we want to analyze. And then we have what we think of as like a file stage. And what happens behind the scenes is Glue's saying, okay, we want to run tasks that apply to files. So I have a file system mounted, whether I got it from GitHub or I got it from the Docker image or I got it from the AMI or I got it from Git, or did I say Git already? I can run things that are just looking at files, right? So theoretically, I can use hashdeep to do basically FIM, so file integrity monitoring, or I can use ClamAV to look for viruses. There are other cool things we could do here. The whole intent is that it's extensible, so we would want to build those out as needed. This is where we kind of make our biggest impact, is in this code stage where we've pulled down the code, now we're going to analyze it, right? So we'll run a bunch of tools. I have a summary of the tools that we'll run, but it's essentially, you can think of it as like we pull the code, we run the tool against the code, we parse the output, which is going to be there a little later, but the code runs, the code analysis runs, we parse the output, we put the results into sort of a common format so that we can handle them in the same way, because we don't really care which tool generated the finding, right? We've written something that will work with Zap, but it's sort of, like we can use the API, drive a Zap scan, get the results out of Zap, create findings for them. That all works. It's not like, I don't think it's robust to the point where I'd say like use this tool to go do that yet. And Zap has a whole independent project to do similar things, so I would look at them first. But the point is this stage is intended to be like a live stage where we're testing against an app that's running or a network that's live. So we might do Nmap. In fact, I have something in progress to do Gauntlet to run Nmap and then check, which ports you intended to open, because this is something that people see a lot with security groups in the cloud, for example, that they didn't mean to open stuff or put the instance in the security group and they end up with ports open they didn't want. So we want to be able to make that easy. Gauntlet isn't, it turns out it's harder to like interact with than I would like, but that's a whole other thing. So then there's this filter stage, and you'll see there's code for each one of these. Like these basically, if you write a lot of code, these each have an interface. And I'll describe the interface in a minute, but you just have to implement that interface to create a new filter or a new app, an analyzer or whatever. But the filter is basically like, we don't want to see false positives in Jira. So for example, with Zap, you will get a different result for iframe options for every different page you hit, right? Well, you only want to see one in most cases because you're going to fix it one time in the web server. You're going to add that header. Does that make sense? So because you fix it in one place, we want to show one finding. If you had a cross-site scripting on 2 different pages, that would be 2 different findings still. You want those both differently. But for something that you're going to fix in one way, we want to make it as clean and easy to get as possible. Now these also, there's lots of opportunity to make those better. So I don't want to oversell this like we have magic that will prevent you from having findings. I would love to have something that does like advanced data stuff here so that you can actually filter in a smarter way, but again, there's extension points for all of these. And then we have the concept of a reporter, and this is where we go to Jira, TeamCity. I wrote in a reporter for Pivotal Tracker. So if you want to take the issues somewhere, you can get them out. You can get them as JSON, you can get them as CSV. We're automating around this, so we clearly want it to be easy to do stuff with the data once you have it. We're not opinionated about where you should put it. Does that make sense? And I'm gonna dive into actual code, but this is a screenshot, and the reason I show it is because I want you to see like this organization of the source code is mapping directly to those things I just showed you. So here we have filters. That was the second to last thing we looked at. Here we have mounters. This is like how we get to Git, how we get to an ISO, right? We're basically, how do we do that stage? So if you want to mount something new, you go look at this base mounter and maybe you implement the methods we'll talk about in a second. For the reporters, you have reporters. So you can go look at the one that's there and copy it and make one for whatever you want. The tasks are really where we're doing more of the analysis. This is a really old snapshot, actually, now that I think about it, because there's like 20 of them now. And then a lot of this is just the kind of code around the code that makes it all work. So let's spend a minute and go. How much do people want to know like the meta, and how much do you want to know like in the code? Do you want to write a new task right now? Should we do it live? Do it live? All right. Can you see that? Kind of not. Sorry, it's hard to get the mouse on the exact thing I want. So let's look at a task for Bandit, for example. This is a good way to kind of see. So remember, tasks are the things that are doing the code analysis. So I have a base task that knows how to report findings. So it implements some base behaviors that I want, so I don't have to re-implement them. And so this Bandit task will inherit from that. Here, I have to add it to sort of the base class so that I know all the tasks. This is how the thing that's running it knows that you have a new task. This just is a bunch of utilities. When I initialize the task, if I say, I want to give it a name and description so you know what's going on, when I assign the stage, that's how it knows when to run it. So if it were a live stage, it would run it as a live tool. The labels are like, okay, this is a code-related tool, this is a Python-related tool. So I could actually pass a label for Python, and any task that's labeled for Python will run. Does that make sense? So you can kind of figure out ways of categorizing your stuff to make it work. And then with an actual task, you just have to implement this run method, an analyze method, and a supported method to have it be sort of a valid task. Because you imagine the task is like a thing, the thing that's running the task doesn't know what it is. All it does is say, hey, I need each task. I want to see if it's supported in this environment I'm in. I want to run it, and then I want to analyze the results. Sometimes running it takes a little while, particularly with like Zap. So here, run, analyze, and this supported method. I think I have a slide that'll show you for each two in a second. If we go back to slides, I don't know. So when I'm running the tools, typically, and in particular, when we build the Docker image, we build a bunch of the tools in. So for anything that's open source, we can build the tools in, right? So we build the Docker image that's it's not as lightweight as it should be. So that's one of the pieces of feedback we have. But we don't know whether to build like a big Docker image that has Java and find bugs, or whether to just build a small one that just has Python, right? So we can tweak that. But what we're ending up doing in the case of Bandit is we're just running a local Bandit program. Bandit is a static analyzer for Python, right? And we're asking for JSON output, and we're running it against the path that we're in. So we've tracked where we are in this root path variable, right? So, and we're taking that JSON result and putting in this class variable result, or this instance variable result. When I'm analyzing it, now we're parsing that into JSON, and for each item that comes back as a result, we're essentially mapping that into how we're going to report the findings. So here, this detail we're pulling out essentially what the text is out of the tool we want into the finding detail that we're going to end up packaging up. So when we see this, if you see this report method, this is a method that's on the base class. And so when we call this, we're passing in the detail, which we got here. So we're basically parsing the XML, the JSON in this case from Bandit, and dropping it into our finding, so that when we report it, we have all that in the same format, no matter which tool we're looking at. It might be useful to look at a different tool here, like so. Well, dependency check's not a good example because it's XML, which makes it hard to read. But like, I don't know. So here we've implemented a helper method, report finding, and we're essentially grabbing things out of a string and then reporting it based on the detail that we get here. So in this case, we're grabbing a description field off of output. You can't see it, so sorry, that's probably not super helpful. The reason we came here was partly to see the tools that we run. So I should mention that we've sort of had to bend the rules for a couple of cases. So you'll see burp, contrast. I can't remember if there's others. Those are things where we'll take the report in some kind of format that they produce and ingest it. So this is almost like ThreadFix, and we're not intending to compete with ThreadFix, but it's almost more like that, where you're taking input from another tool and pushing it where you want it, right? We're not running burp or contrast in that case, right? We did write an adapter for checkmarks, so you could run checkmarks as part of your analysis and get the detail and put it in Jira. That was a pain, and it's against the old API, which is SOAP-based, so you might not want to use that part. We probably need to rewrite that. So if you're at a company where you want to use this and you're using commercial tools, you may end up having to write your own tasks, which is part of why we could talk about that. So let's just sort of, so I showed you the Docker command to run this. If I want to run it, locally, like while I'm working, I can just run this bin glue. So I don't know if you can see this down here, but that's like what ends up being your command line. And you just basically say glue task, and I had made a sort of messing around and made a new task. And so I can run a new task against Defect Dojo by doing this, and it's pretty fast. But in the meantime, let's talk about what it looks like to implement a new task, because that'll be fun. So let's say I want to just do, there's a tool in Python called safety. Does anybody work in Python a lot and know that tool? Right, so there's a tool called safety check. It's like dependency check, but for Python libraries. So let's write that real quick. So if I go, maybe I'm going to go safety check, or that's fine. And so you get an empty Ruby file, which is not all that helpful, but might as well start with the Bandit code, because copy and paste is great, right? Let's call it safety check. And we can leave it as source code. We can leave all that. That's why I copied that one. So then I have to figure out how I'm going to run safety check. Well, I spent just a little bit of time making sure I knew how that works so that it would work. And it looks something like this, where I say safety check, and I pass this JSON thing, and I pass this -r to the requirements.txt, and safety runs and shows me the vulnerabilities that that app has, right? So now I can say, well, let's just, I'm gonna go over here. So here I've got, sorry, I actually tested this in advance, which should make you happy. So here's how I would set up that command to run. And I'm assigning the results of the output into this result thing. Now let's just actually delete this for a minute. So analyze is empty, but let's just do puts. result. And then let's just do this. This is kind of dumb, but I don't know if this is going to work actually. If it's smart enough to tell me that it's not there. So if I run this now, and this is case insensitive, it basically pulls the defect dojo code. Let me make that larger. And it works the same way when you run it in the Docker image. The Docker image is pulling the source code from wherever it is, grabbing it, running the analysis. And here we've just pulled, so we've run safety check and got it into that result object, right? So to finish writing this check, we would implement this supported method where we would basically, I looked at this too, and the way to do this, it seemed like, was to say, and every tool's different, right? So safety doesn't have a version. Usually I like to do it with like, oh, how do I know the tool's here? I can say, run it with version and get a result like, oh yeah, we're version 1.2, right? So in this case, it looks more like, ended up looking more like this, where you can run it, and if you run the help essentially on safety, you can know if it's there or not, right? And if it's not available, you'll just obviously not run. The analyze gets a little trickier, so I was kind of preparing for this, and I wasn't really planning on doing anything live, but we would start to basically parse out the JSON we get back and map it into the finding that we have. And the finding that we have is pretty simple. Let me show you that real quick. It's basically got the task, the app name, when it was found, some sort of severity, the source, which is like what tool found the finding, description, detail, which I think are self-explanatory, and then the concept of a fingerprint. And this is really important. If you implement a new task, you need to make sure you think about how the fingerprint is going to work, because if you can make something that's unique for that finding, we can be sure we're not producing the same thing again. Does that make sense? Without that, we can't know. So fingerprints, some tools, like Brakeman, for example, produces its own fingerprint, so we just use that. In other cases, we use a combination of the file, the line, which of course is flawed, right? Because if we just use a file and line, the same code could be flawed and move, and we'll report it again. But we decided, like, we don't want to be too smart. For most cases, we'd rather report something again if it moves around, because we're not a static analyzer. We don't understand what's happening in the code, right? We're just tracking where that thing was found. Does that make sense? But the fingerprint essentially gets reported in the detail of the finding, and then let's say we're reporting it to Jira. You can imagine that we say, push it to Jira, and then, oh, don't push it if this fingerprint exists in Jira already. So if the fingerprint exists already, we won't report it again. Great, but that's why the fingerprint is really important. It's usually like the type of finding, where it is. If it's like live, it might be the page, the field. Does that make sense? So let me go back to the meta for a second, and we can dive back in here. So you can see that we have Bandit. I was working on Gauntlet, but I haven't finished it yet. Brakeman, bundler audit is basically similar to Brakeman. It's going to do dependency type of checking for Ruby. Burp, I mentioned we ingest the findings. Checkmarks, we run a scan over the SOAP API. ClamAV just runs ClamAV. Contrast ingests a report. Dawn Scanner is similar to Ruby, to Brakeman. We did a lot of work with companies that were using Ruby. That's why there's such a focus there. This dynamic one is something that Omer is working on, where it's going to be more flexible about what tools even being run and how the input gets parsed, so that you can write like almost like a DSL, so you can write something around how you run the tool and get the results back out. I haven't actually used it yet. We'll run ESLint, which is like a JavaScript tool, so you can use ESLint with security checks, and it'll find sometimes things in JavaScript. We'll run find security bugs. We don't have a great rule set for find security bugs, because the security rule set for find security bugs is but it will find certain things. NPM, I don't know if NPM is still, this probably needs to get updated now that there's an NPM audit function, so I think that's probably old. But we will also run dependency check, so we'll run Java dependency check against projects and take the findings out of the XML that we get back and push them into Jira. We had some PMD security rules, which this is primarily like a Java static analysis tool, right? Retire shows you JavaScript, old JavaScript libraries. We just did the safety check one. I was working on a Scout 2 integration, so that I don't know if anybody's heard of Scout 2, but if you supply AWS credentials, you could run Scout 2, have it pull out the stuff, push them into Jira. That's kind of hot if I could get it done. Just haven't had the time. This SFL looks at sensitive files. SNCC is, I don't know if you're familiar, but it's also dependencies. Trufflehog is looking for like creds. Yeah, like strings that have high entropy. And then Zap connects to Zap over the API, runs a scan, and gets the results back. So I like to think that it's pretty simple, but let me go back to the presentation so you can see like what the actual extension points are, because that's useful, right? So if you're going to write a mounter, you're going to write something that says support. So how do you know that you can mount that kind of thing? And then the actual mount function. And the mount function has to actually result in that file system being available for us to do the further analysis, right? Tasks, I mentioned this, you have to write the run, analyze, and supported methods. For filters, there's just one method called filter, and it essentially takes the array of findings, and you can do whatever you want to remove them. So I wrote a dumb filter that just zeroes out the array. So you'll never get any findings, right? But you could filter on anything. You can inspect the findings and say, I don't care about these because whatever, right? The Jira filter is one that doesn't just sit there in place and look at those findings. For each one of those, it connects to Jira and asks, do we know about this one already? That's how that's implemented. And then the run report is the thing that actually takes the findings array that you end up with after the filter runs and pushes them out to wherever you want it to go. So I think of these as being tasks, these files, code, and app things. So this is where all the analysis actually happens. Here, we're just getting the stuff. After this, we're filtering it and reporting it. Does that make sense? I think I just said that. So you can also just run like against the file system. So if you're building something locally, you can do that. Some checks are really good. I just went through them all. Others are still noisy. The whole goal here is to run this, like make it easy to run these tools every day, right? So how can you do that? One way you can do it is you can run Jenkins, right? So if you're running Jenkins already, you can run our stuff, this glue tool, right in Jenkins. And the idea is you can set up a, what am I doing here? I'm setting up the managed scripts plugin in particular because you need that. And then I build a project. In this case, I built a whole separate project for this just because that seemed like the best way to kind of isolate it. And then you go to this on the left, if you go to config, you go to this config file manager, you can add a managed script, and here's this pipeline build script. And then you can basically run the same Docker thing you'd run locally, and Jenkins will just run that as part of your build. And so then you can fail the build because your thing didn't run. Does that make sense? That's step one, right? And of course, because we're all about DevOps, we want to see it in Slack. So that's not anything we do, that's just Jenkins Slack stuff. But it's kind of cool to be able to know that that's easy, right? Like Jenkins has a Slack, I mean, setting that up is literally following a 5-minute Slack FAQ, right? That sounded funny. Then you get builds that work and don't work, etc. I don't think you need to see the details here. We just talked about all those, so I'm going to skip that. So this starts to get interesting because, so we packaged it as a Docker image initially for portability because we're like, oh, wouldn't it be cool if you could just run it over there without having to set up PMD, right? Like, who knows how to set up Maven so you can run find bugs, right? It just, like, all these different things seem like a pain. So how can we do that? Well, that's why we chose to build a Docker image. But once you have the Docker image, now you can do some really interesting things, and I wouldn't actually do this through the GUI. I'll show you the scripts that you can use that are in the Glue repo now. But you can run Glue in, obviously, in a job in Kubernetes. So let me show you what that might look like. And again, this is really more like the it's more the integrations and understanding how Kubernetes and Docker work than anything we did in the Glue project, right? So this is just like a demo script we package so that you could set up a Glue pod to run triage, run glue on triage. Triage is that intentionally vulnerable project I keep referring to, right? So if I do this, this will create a container and run glue, and just this one just runs it one time. So I can just go, if I have this YAML file, which describes sort of a pod, which is a Kubernetes thing, if you don't know, and then this OWASP glue is the image, so this is published to Docker Hub, so you can just go docker pull OWASP glue, that's why this works. And then I run the command, and you hopefully are starting to get familiar with what the syntax of the command is, because I've been showing it so much, right? Like there's the tool brakeman against the triage thing. Well, if I want to, so this is just a YAML file that describes a pod. If I want to set that up, I can say kube control create based on this. And I may or may not do that based on time, but it's not a big deal. I'm running Minikube here. You could just basically go create the command and it'll run it one time, and then you can look at the logs and see what happens and delete it, right? Now, I'm sure that what you'd actually want to do is use secrets so that you know how to connect to Jira, and you'd want to have this set up on a cron. So you can also set up like an integration where you have a cron in Kubernetes. So this is kind of cool because Kubernetes just runs the job for you. You don't even have to know what it is. So here I've got a cron. This is every 30 minutes. It's the same concept of the container. This isn't the same as the last one, but now I can run. So this will, if I set up this cron every 30 minutes, it's going to run brakeman against my project. And if I set it up properly, it's not in this command line, but I can make it report the issues to Jira, right? So now with almost no work, but you can copy this script out of your thing, change the command to run the tools you want, integrate it to Jira. Now you've got, if you can set up a little Kubernetes cluster to work with, now you've got whatever security tools Glue supports, pushing stuff to Jira with like no work. Does that make sense? Not no work, that's total simplification, but that's the idea. So I also, in a past life, built vulnerability scanners, and we used to have literally like a rack machine for each scanner. So we had, and it wasn't that big a company, but we had thousands of them, not tens of thousands, but like we had a lot of them, right? And then what we built was all the like smartness to figure out how to manage those and like distribute jobs across different scanners and so forth. If you do this, because it's all sort of shared resources, a lot of this Kubernetes takes care of you for you. So like to build a cluster of scanners in Kubernetes is like kind of a cool, easy thing to do, right? And again, I wouldn't tell you to use this for Zap because I think Zap has a whole roadmap for doing this that's cool. But for a lot of this stuff, I think it makes it easy. If you want to set up Glue in Jenkins, this is an example of a script. So these are pushed to the repo, right? So in GitHub, you can go look at the Glue repo, and we have these sample integrations. Sorry, because of where I am, you can't see this very well. But there's this integrations folder, right? So one thing you could do, let me step back. One thing you could do is run it as a pre-commit hook, right? So you could have git commit and run something and have that either succeed or fail based on what runs. So because you only want to run things that are really fast in that kind of spot, you don't want to run Zap every commit, and you don't want to run anything that's like going to take more than a couple seconds at the very most, right? You want to be careful about what you do. I would recommend running like the secrets manager or something like that, like the SFL tool. But if you know how git commit hooks work, it basically means that when I do my git commit as a developer, it has to meet some criteria before it'll let me commit. People often use these to do things like make sure the Jira issue is in the name of the commit message, right? But we can use it to do other things too. If you want to go beyond that, now you can go say, I want to set up a managed script where Jenkins is going to run, in this case, Jenkins is going to run Glue. It's going to run, well, this is the active one. But Jenkins will, if you're using Jenkins to do deployments, it may also know what's running. So you might be able to integrate this into your deployment where you're running Jenkins, you push the thing, you can run Zap now. But what I would expect more likely would be that you'd want to run it against source code on every commit or something like that, on every push to master. And then you can build like a pipeline. So if you're working in Jenkins, you have this fun thing called pipelines, right? So you can then write Groovy code to set up each one to do what you want. And this is what it would look like if you wanted to run the Docker image in Jenkins as a stage in your pipeline. I think I'm almost out of time, so I'm going to just finish and then take whatever questions. I mentioned that Omer is working on dynamic tasks. I would need to defer to him to explain what he wants to do there, to be honest. We've written a bunch of tests, but we need to write more tests. So I think if that's one of the things we'll end up spending time on. It's a little tricky because, as you can imagine, right, we're shelling out, running a tool, getting the results. To write really good tests, you need to see a lot of different scenarios. And so most of the time, by the time we've done tool integration, we've got the environment working, and it's hard to come up with why it would fail. So it's like many things, just an exercise in writing better tests. We also need to improve documentation. So like this Kubernetes thing has always been possible, but nobody knows how to do it. So we can't say, hey, anybody who wants to just run a scan cluster, you can start up and go, right? Like nobody knows how to do that. So we need to improve that. I think there's easy opportunities to run more tools like safety check. Like I should probably polish that up, make it work and commit it. It's nice to have. I think from a big picture, I feel like beyond this, the tool needs to get kind of consolidated. But what I usually tell people is use it as like your first stage of thinking about how you're going to do automation. It's not like the whole end game, right? So a lot of the people we talk to, and my firm works mostly with very smaller companies. So they're usually like figuring out what to do from an AppSec perspective. And they're like, let me buy a tool, right? I'm like, well, that's cool. Tools are really good. Like the tools are better than what's in here probably, like bluntly, right? If you use a commercial tool for any one of these scanning pieces, it's probably going to give you better results than what we can run from open source. Probably, not definitely, but probably. But if you don't know how that tool is going to fit into your process or anything like that, then it's hard to know that you're going to use it successfully. But if you have some engineering resources and you can do this, now you've got something and you can build the tools into that. Does that make sense? So you can sort of build the automation and flow such that you could take a tool, plug it in, and get the better results you wanted anyway. Does that make sense? So that's basically it. We already did the live write a task as we go. Did the run, mount, supported, and analyze make sense? Cool. Anybody else have questions? Thanks for coming. I really appreciate it. It's been really a fun project for me because I spent a lot of time on it and I haven't been able to spend as much time, but Omer's picked it up and like really run with it. And so it's kind of like, I don't know, if you work in open source, it's kind of like a great thing when somebody else picks up and runs with something you start. Like that's not a common experience. So I really appreciate that.
So the things that you said you're looking to add, like better tests and documents,
Yep.
that would probably be a great place for folks to look for and contribute.
That would be great. I'm of two minds about that because I think a lot of people in open source always say you can start with tests and docs, and then people aren't as interested in that part, so then they don't engage, right? So I would almost say find the thing you want and build that. You know what I mean? Like if there's a tool you want, I think we would be happy to talk to you about how to do the integration or like bounce ideas or whatever. But my thinking would be do that, and we collectively need to just do a better job with testing and documentation. Because again, it's not that it's wrong. It is an easier way to contribute. But it's not the fun way to contribute for a lot of people, so I would say don't feel constrained to that. This is off the topic. I did a whole talk about writing security unit tests. I would love to build some kind of like bootstrapping thing where this can give you a whole bunch of frameworks for that, and we could like pull tests from Git and then run those and then push the findings to Jira. But like that's outside the scope of what I have time for. Thanks for coming. Have a great day.